Hello everyone, this is Billy Younger again. I'm going to teach you how to use the simple wave equation. That's velocity equals frequency times wavelength. This is mostly for my astronomy and my conceptual physics types courses, ones where math isn't the critical thing. So I'll show you a way to avoid actually doing algebra. And I'm going to use it in the context of AM and FM radio stations so that we can learn a little bit about those as well. So I'd like to start off by showing you the equations. Then I'm going to show you how to solve them, specifically in a way without algebra. And then I'm going to show you how to put it in on a calculator where you only use one button. Of course, there's easier ways, but they require multiple buttons and sometimes take a little bit of time to figure out how to use it. So let's get started. I'm going to turn my document came on. So the simple wave equation that we're talking about here is the one that says velocity is equal to frequency times wavelength. That is the Greek letter lambda, and that represents wavelength. That usually has units of meters. This is the frequency. The wavelength really is, if you draw a wave like this, the wavelength would be the length from crest to crest. It's measured in meters or centimeters or miles or feet or something along those lines. So that's the wavelength. You could also measure it from trough to trough, and that would do the same thing. That's also the wavelength. Or you could go from this spot here all the way to this spot. That's the wavelength as well. Notice I had to skip a middle spot to get the wavelength there. The frequency is the number of waves that pass by every second, and that's measured in cycles per second, or hertz. Hz is the way that's abbreviated, capital H, lowercase z, and this is measured in meters per second. Okay, if we happen to be talking about the electromagnetic spectrum, which includes gamma rays, X rays, ultraviolet, visible, infrared, microwave, and radio waves, and they all have the same speed, V equals C, which is 299,792,458 meters per second exactly. Okay, we can estimate this to be approximately 3.00 times 10 to the eighth meters per second. So that's the velocity equation or the wave equation. And I'll show you that in order to avoid doing any algebra to solve for it, you can make a circle. And this actually works with all equations where you have one variable alone and then a string of variables next to each other, like the Drake equation or something like this. So you take the one variable that's by itself, you cut the circle in half, and you put the one variable that's by itself on top, and then you separate into little spots all the things that are being multiplied. Now this is two things, so I only need one line. If I had three factors, I'd need two lines. If I had four factors, I'd need three lines, so on and so forth. But in this case, I'm just going to put F and lambda. Now, in order to solve this equation for wavelength, you cover up the wavelength. That looks like velocity is being divided by frequency, and that is exactly how you do it. If you want to solve for frequency, you cover up frequency. That looks like the velocity is being divided by the wavelength, and that is exactly how you do it. And finally, if you wish to know the velocity, you cover up the velocity, and that looks like you're multiplying frequency times wavelength, and that's right as well. The big thing is you just got to make sure you have it all in the right units. That's why I put these units up here: meters, hertz, and meters per second. So we're not going to use kilometers. We're not going to use megahertz, kilohertz. We're going to make sure everything's in the proper units. So as a first example, I'd like to ask you, what is the wavelength of AM 850? That's a radio station that I'll listen to around here. And we want to know what the wavelength is. And I'll just call this lambda 850 to make it simpler. Now, according to this, lambda 850 is equal to the velocity divided by the frequency. Well, the waves that come from a radio station are actually carrier waves that carry the signal, in this case, in the amplitude. It's amplitude modulated, hence the AM. Uh, and since that's a radio wave, we know it's an electromagnetic wave, and therefore it travels at that same speed. So this is actually just taking 3.00 times 10 to the eighth meters per second and dividing it by the frequency. And here's the part where we're going to learn something. It turns out that the radio stations are really the frequencies, but in very specific units. The frequency, for instance, the AM 850 suggests that the frequency is actually 850 kilohertz, which we write as 850 times 10 to the third hertz. So I'll write down here 850 times 10 to the third hertz, and hertz is basically the same thing as 1/seconds. When you divide these two, you end up getting 352.94, and this would be meters per second divided by 1/seconds. When you divide by a fraction, you just flip it over, so that'll be seconds over 1, and you see that the actual units of seconds cancel out with one another. And now I'm going to use the fact that this had 3 significant figures, and I'm going to pretend this one has 3 significant figures. That 0 may or may not be. So I'm going to round it to basically 353 meters. So the wavelength of the carrier wave for AM 850 has a length of about 353 meters, which is on the order of 4 football fields. Pretty good size. Now I will show you how to do this in a calculator, again using exactly one button, and I'll explain what other things you could do as we go along in case you're a little more savvy with your calculator. So to implement this on a calculator, I'd type 3.00, and then your calculator is going to have either an E button or it'll have an EXP button. Whichever button it has, you hit that, and then you do 8, and that gives me 3 times 10 to the 8th. Then I'll hit my divide by button, which might be 2 dots separated by a horizontal slash, a virgule, I believe it's called, or it might just be a slash like this. Now we type in 850, and again, kilohertz is 1,000 hertz, so I have to multiply it by 1 followed by 3 zeros, which is the same thing as times 10 to the 3. So I'm going to again use either my EE button or my EXP button, whichever one your calculator has, and then 3, and then most calculators will require you to hit equals, but some will not, so I'll just put a little question mark over that. So that's how we go about calculating the wavelength using a calculator. Now, as another example, I wanted to quickly show you what the wavelength of FM 93.7 is. So I'd like to know the wavelength of FM 93.7. We'll say that's equal to question mark. Again, this is a radio wave. This one's actually frequency modulated, and that means the distance apart is multiplied by the actual sound signal, and you have to separate that part of the circuit out. But we'll also call this lambda 93.7 because that doesn't really provide any extra ambiguity because there are no 93.7 stations on the AM band. And what does that FM mean? Well, that FM station, that corresponds to the frequency too, but it's in the different units. So what we know is that this would suggest the frequency of 93.7 FM is actually 93.7 megahertz. And mega means a million hertz. So it'd be 93.7 times 10 to the 6 hertz. So again, using my circle, I know that I'll just cover up the wavelength. That'll give me velocity divided by frequency. So the wavelength of 93.7 is just going to be 3.00 times 10 to the 8th meters per second divided by 93.7 times 10 to the 6th hertz. And this gives me an answer of 3.2017. And notice it's meters per second again, divided by hertz, and hertz is 1/second. So when I multiply it, I have to flip it over. So that's seconds over 1. So again, we see these seconds are canceling out, and I'm just left with, again, assuming 3 sig figs, which most astronomy and conceptual classes don't worry too much about, that's going to assume that the answer should be written as 3.20 meters. Okay. Again, how would you do this in a calculator? It's the same process we did before, 3.00. We type that in, then we type either EE or EXP, and then we type in 8. And then again, we're going to use our division symbol, either this or the slash. And then we type in this case, 93.7. Again, EE or slash. And then in this case, we're going to type a 6 there instead of a 3. And again, we may or may not have to hit equals, so I'll put a question mark there. So that's how you go about doing those problems. I'll solve another one later on showing you how to solve for frequency. And I think you can tell how you're going to solve for velocity. Obviously, according to the circle, you're just going to multiply frequency times wavelength. Long as this is in hertz and this is in meters, it should come out to meters times 1/seconds, which is meters per second. I hope that helps.